Okay, hi and welcome to Notes 8.3 and 8.5 Properties of Exponents Day 2. So we're going to start talking about some of these properties that we've had before, and then we'll finish off with two new ones, and we'll get right to the examples. Again, most of these are sight, seen, and kind of understood, so not a lot of explanation. Ones that we've talked about before is multiplying like bases with powers, and you can see here the A is, and when we do that, we add exponents as you can see here. If we have a base raised to an exponent raised to another one, we call that power to a power. In that case, we multiply exponents. You can see that there. Power of a product, meaning that there's more than one thing inside of the parentheses, and it's raised to a power, so power of a product, meaning multiplication. In this case, everything inside of the parentheses gets the particular exponent, as you can see here. So I don't want to call it distribute, but everything gets it. Everything. And I'll explain later why, in a different unit, why we don't say distributive property, because that will cause you an issue if you do later. We also talked about the negative exponent, which means to move either position. So if it's in the numerator as it's seen there, you take the base and the exponent, move its position, and change signs. So make sure that you change the sign. And then, of course, the easiest one of all is if you see a 0 for an exponent, it's always equal to 1 regardless of what that base is. All right, so the two new properties we're going to talk about today then is dividing powers. Dividing powers, you can see that it's right above here. Multiplying powers, as you suspect, if your exponents are being added with multiplying powers, that dividing powers, then your exponents are going to subtract. So the way this works, and we'll write out both forms here, is there's two ways to do it. Because there's an A to an M and an A to an N, we can actually reverse it and change its position to that location. So if I take the same base, here's the base, and as you suspect, we're going to subtract. If I take M minus N, that's going to stay in the numerator. That's really strange to say. The other way that you can do it is you can take it to the denominator and do the same thing. However, be very mindful of what I'm writing here. This is N minus M. So, which way you choose here in this scenario determines where it ends up. So you can make the subtraction in the numerator if you take that exponent, and you can make it in the denominator. So the first exponent that you subtract, or that you have in your subtraction, determines its position. If it's the new exponent in the numerator, if that's your first one, then it goes in the numerator. If it's the denominator's exponent that's first, as in the second example here, then it goes in the denominator. So be very careful with that. It's a powerful rule if you know that part of it. If you don't, you're going to make lots of mistakes because you'll always put it in the numerator and you'll get some wrong answers because of it. All right, the second rule we're going to do is a power of a quotient. So I didn't write subtraction here, but we're going to write subtraction. Power of a quotient is very similar to what you see here with power of a product. It's kind of the same scenario. I don't want to cover up my end there. Let me move that arrow. It's the same scenario. So this is a multiplication. Everything gets the exponent. And guess what? Here in power of a quotient, right? It's a division as opposed to a multiplication. Everything gets the exponent. So that one's actually pretty easy. You'll do fine with that one. So A gets the power of M and B gets the power of M. So now that we've got those done, let's do some examples so you can see what you're up against here. So here's a nice one. It's real simple to start. We've got the same base of A. Remember that your bases have to be the same. They can't be different bases. It doesn't work. So I'm going to put this in the numerator because that's going to leave me, if you look carefully, I've got a 16 and a 14. Well, if I subtract 16 from 14, I get a positive. I don't have to move anything. But if I subtract 14 from 16, I get a negative 2. It means I have to move something. That's an extra step. So when you do this division or dividing powers, make sure that you're being mindful of where it's going to be positive, or which way you subtract it, it's going to be positive. So go ahead and take that into account. Let's do this. This is what this is going to look like. We end up under the same base, and then we subtract the exponents of 16 minus 14, which is going to give me A to the second. Okay, just on the other side of things, here's your OR, just so you can see it. If we subtract it the other way, it would look like this. 1 over A to the 14 minus 16, and we would get A, 1 over A to the, oops, I don't have a lot of room here. Let me try to squeeze this in. 1 over A to the negative half, in which case that would tell us to move it to the numerator, and we end up in the same spot. So, multiple ways to attack these. Just be mindful and make sure that you have the basic parts of that rule. All right, so looking at this one, we've got lots of things we can do. We've got negative exponents. We can move them. We can apply our power of a quotient rule because there's same bases here, so we can do a subtraction. That's what we're going to practice in this scenario. We're not going to practice moving the negative because we've already done that. So if I look at this and I want to keep this c value positive as an exponent, then I don't want to have to move it. I probably want to subtract 5 minus this 1. That's going to keep it positive, which means I have to have it in the denominator. So I'm going to go ahead and draw a line here. And I'm going to say c then 5 minus, and that's a negative 1, so I'm going to keep track of that as well. Don't lose a negative in this process here, right? So my 5 minus 1, which is going to be plus, right? So in here, my d's, if I take this 3 down here, I'm going to get negative 7 because I'm going to subtract 4 from minus a negative 7. So I really want to take this d to the numerator. So this d then, and again, pulling down my note here in a second, the first exponent determines its position. Well, I want the 3 to be in the numerator here, and I'm going to subtract a negative 4. Okay, so take a look at that. Let that sink in for a second. Once it does, it clicks and you'll be good. But let's go ahead and finish this up. So this is going to be d to the 7th and c to the 6th. Why is it 7? Because these two make a positive as well as those two make a positive. So don't lose those negatives when you're doing this power of a quotient rule and deciding where they go. Here's a couple other examples you can take a look at. Nothing particular. We'll just take a peek at 4. Same bases, right? I've got a 2 and a 4. If I want to keep this positive, I want to subtract this 2 down. So that's why the a has a 4 minus 2 in the denominator, because that keeps it positive. And the same thing with the b's. There's a unsaid 1 there. I'm going to subtract 3 from 1. That's going to keep that as a b squared and put it in the denominator as well. So you can see that going to the numerator is not always the best scenario. However, you're going to want to do that, but be mindful. All right, so now that we're done with that section, let's move down here and see that same set of rules working with scientific notation. Because as we know, scientific notation is operating under exponent properties quite frequently. Now with this, remember, we treated these in the previous section as just multiplications of regular numbers. And likewise, we're going to do that here. We're going to treat these likewise as a division of numbers. So 2 divided by 4 reduces to 1/4, which turns into 1/4. So I'm going to put 0.25 because that's what I wanted as a decimal, not a fraction this time because it's in scientific notation. And then I'm going to put my multiplication. Here's what we have to do now. I need these values to end up in the numerator and positive. So I'm going to go ahead and move this 8 up. Actually, I take that back. I don't need them to be positive. With scientific notation, we can have negative exponents. It's okay. What's it tell us to do? It tells us to move the decimal to the left, right, as we undo it. So it's okay to have negatives with scientific notation. Here, when we're solving general purpose terms and expressions, we don't want a negative. But in scientific notation, negative exponents are okay. So we'll write that little note down. Negative exponents are okay in this scenario. So I'm going to go ahead and take this 8 up to the top, which means it's going to be 10 raised to the power of 3 minus 8. Okay, and then I'm going to write down 0.25 times 10 to the negative 5th. I'm okay with that. However, we're not quite done because this value, 0.25, is not between 1 and 10, right? So I've got to move this decimal once to the right. And if you remember, moving to the right should make my value get more negative. So I'm going to end up with 2.5 times 10 to the negative 6th. Okay, there you go. And there's a couple other examples to take a look at. You can compare them and go ahead and make some assumptions. Again, it's something that you just need to see, not anything I need to talk about. All right, so here's some various forms of some expressions you're going to see. This one's actually playing off of the power of a quotient rule, so you can see some examples. In here, you've got 4 divided by x squared, and it's all raised to the 3rd power. So let's see what that looks like. In the rule, it says everything gets the 3, all bases. So we're going to go ahead and say 4 gets the power of 3 and x gets the power of 3, but that's power to a power because there's a base with an exponent and it's raised to another exponent. So that means 2 times 3, right? Not a multiplication, not a division, that you're adding and subtracting exponents. This is raised to a power, which indicates multiplication. So 4 to the 3rd, I believe, is 81. We'll pull our calculator up here and check again just to make sure and review how to do this. We'll clear this off. 4 caret key, remember that's how you get your exponent to the 3rd, is going to be 64. I was a little off there. So we've got 64, cleaning that up in the numerator, and x times, or raised to the power of 2 times 3, or 6. And we're done. There's nothing else to move. The x doesn't have to be in the numerator. That negative, that exponent is not negative. Again, a couple other examples so you can see that there, and we'll do a couple last set of examples here to kind of clean up and be done with this. So in this scenario, you're going to get a mix of both rules. Here's your power of a quotient. That's some values being divided raised to a power, and you have a negative in there as well. So actually, you don't see any subtraction of exponents here, but that's okay. So we're going to go ahead and apply this just like we did before. The 2 gets the -4, the x gets the -4, the y gets the -4, and if you will, there's 2 ways to think about this. One, because it's an even exponent, even though it's negative, right? We know our result's going to be positive for any negative basis. Why do I bring that up? Because we have a negative there. What's it really mean? Well, out in front, if you want, you could do this. Now, it's -1 to the -4, because technically there is a -1 here. Technically, it is a base. But what happens there? Well, that's what this rule is explaining. So that's the shortcut of the rule, or like a summary of it. But here's what's actually happening. I'm taking -1 and I'm multiplying it by itself -4 times. Well, if you want to flip it and put it in the denominator, go ahead. It doesn't make a difference. We've already talked about a negative being out front. In the numerator and the denominator, they're all the same. So if you put it in the denominator, now you got a +4. Well, what's -1 to the 4th? Well, it's -1 times -1, that makes it positive, times another -1 times another -1, which makes it positive. So the result of this whole bit is that the negative part of this turns positive. That's why we have this rule. If you have a even power raised to a negative base of some fashion, it becomes positive. If it was odd, it would stay negative. So that's what that rule means. That's what we talked about. You don't have to do this part here. This is just me discussing it. So let's finish off. Now we know the whole thing's going to positive. We don't even have to pay attention to this part. We already talked about that. So we've got 2 to the -4th, x to the -4th, y to the -4th. None of them are the same base, so all we're going to do is move positions at this point. The y is going to go to the numerator and y to the 4th. The 2 is going to go to the denominator, and that's going to be 16. Right? Because that's going to be 2 to the +4 when we're all done, so 16. And then x goes to the denominator as a +4 as well. So lots of moving parts, all simple to keep track of as long as you know these rules and all the little parts that make them work. So make sure you know these rules, put them somewhere, tally them all up over all 3 days, these properties, have them all in one spot so you can go look at them somewhere. But that's all said and done. I'll see you in class for some questions and examples, and